Hey folks, welcome to Unit 3, which is the unit on work, energy, and power. This unit presents a totally different way of thinking about physics, but it's all the same physics that we're thinking about, which is the good news. This video will serve as an introduction to energy, and then an introduction to specifically a type of kinetic energy. So here we go. We're going to start by defining energy. Energy is kind of difficult to define because it's kind of like a made-up idea. That idea is just really good at explaining a whole bunch of things. So energy, unlike everything we've learned about so far, is a scalar. So we bounce back and forth in between scalars and vectors for the first part of the course, and almost everything in energy is a scalar quantity, meaning it's just a number with units. It is a scalar that describes the state of a system. Now, the word state, it can actually mean the state of matter. If it's a solid, liquid, or a gas, that comes with a certain amount of energy stored in the substance itself. But it usually just describes generally the system. So how fast it's moving, how far apart things are, how they are oriented with one another, what types of particles we're talking about interacting. It's a very general description. In physics, in this physics course, we are specifically talking about energy as the ability to exert a force. So things that have energy are able to exert forces based on either the fact that they're moving or that they've stored energy and then can release it in order to exert a force. The unit for energy, and it's the same for all types of energy we talk about, and even work, which we talk about later in the unit, is the joule, capital J. The joule is a derived unit, so a joule is a kilogram meter squared per second squared, which doesn't mean a lot to us, which is why making this unit up, calling it joules, makes it just easier to understand. For perspective, 1 joule is equal to 2.4 times 10 to the negative 4th food calories. So it's not a lot of energy at all. 1 joule is a tiny amount of energy. And when we do things in the lab, we're also going to be using mostly tiny amounts of energy because we need them to be safe. What follows is categorization of a bunch of different energy types that you may or may not be familiar with. We're going to group them into whether they're kinetic or potential. Kinetic energy is based around motion. So the more motion something has, the more kinetic energy it has. Potential is about storing energy. So stored energy is potential. There are different ways to store energy, but it's based on like the organization of the particles in the system. The other category we're going to use are mechanical versus non-mechanical. Now, for us, mechanical energy is like a macro idea. Like if we can see the things doing, like exerting forces on one another or interacting, then it's probably mechanical energy that we're describing. Whereas non-mechanical energy, it's really the same thing, but it's on a micro scale where we can't see the particles interacting, we can't see how they're arranged, but we see their effects. And so we're going to group everything into these kind of 2 sets of categories. So in this course, we learn only about mechanical energy. There are 3 types of kinetic energy. Translational, which is movement from place to place. We'll learn about that in this video. Rotational, which is moving around and around, spinning, basically. We'll learn about that later in the course. And then vibrational, which in this course, we don't really call it vibrational energy, but when we talk about springs oscillating, so springs oscillating up and down, that's a vibrational kinetic energy. The types of kinetic energy we don't study in this course, but are part of physics nonetheless, are thermal. You usually learn about that in high school in chemistry, where you learn about like heat transfer between hot and cold things, and also chemicals that are reacting and their surroundings. That's based on like the motion of the particles of a substance. Then we also have electromagnetic. That's a huge category. That's like an entire physics course that you could take next year if you were a junior this year. It's based on electricity, magnetism, and light. Motion of charged particles and behavior of charged particles can create different forces or phenomena, and the motion of them is their energy. And then last but not least, we have sound. Now, this is not all of the types of kinetic energy, but it's like a pretty good representation. And sound is just like the vibration of particles carrying energy throughout a substance. So everything here is based on motion. Potential energy is all based on somehow storing energy and releasing it later. So in this course, we learn about two: gravitational, which is using the force of gravity to store energy. So if you have gravity between two objects, there's like a tension almost, and bringing those objects together would release that gravitational energy. Elastic is the other one, and so this is anything that can stretch or deform. When you stretch or deform it, it stores energy in itself, and then that can be released and exert a force. Non-mechanical types of potential energy would be nuclear. This is like the protons, the protons and neutrons in a nucleus storing energy with one another that can then be released. You're thinking like nuclear reactors or bombs. Chemical is a type of potential energy. So every chemical bond between two atoms stores a specific amount of energy, depending on the elements and how many bonds there are between those elements. And so that can be released also in a chemical reaction. And then electrostatic is another one. Again, not a complete list, but just some examples. That would be like charged particles causing an attraction or repulsion, and storing energy. So if you like get zapped by your car door or something like that in the winter, you're experiencing a discharge of electricity, and that was there because there was electrostatic energy stored between the two of you, the door and yourself. So that's just an overview. Now, none of this is really on the test, but this hopefully like gives you a little bit of a framing of what energy is all about. It's really about everything. And then our course is focused on the top half of this table. Last part of the video is translational kinetic energy. That's the first type of energy that we learn about. It has the symbol K, is energy due to the motion of a system's center of mass. So if it's one object and that object moves from one place to another, we call that translational kinetic energy. If there's multiple objects and the motion causes the center of mass to move, that's also translational kinetic energy. The formula for translational kinetic energy is 1/2 mv squared, where m is the mass of the system and v is the speed of the system. And that's kind of it. Kinetic energy is pretty simple. It's just if it's moving, it has it. If it's not moving, it doesn't. So to end this video, I want to do one last thing. The formula for kinetic energy is 1/2 mv squared. Well, mass and speed have units. And so if I take the units of mass and multiply them by the units of speed squared, I get kilogram meters squared per second squared. And at the top of this sheet, at the beginning of the video, I defined this as what a joule is. And I won't do this for all the types of energy, but just to show you that every type of energy does have the same units, no matter what the formula might say. That's it.